Ladies and gentlemen, so product and quotient rule. So as you can tell, this is the product rule. How do you know it's a product? Because I am taking two functions and I am multiplying them. And what they want me to do is they want me to take a derivative. So what you're going to do, and this is how I do it, I take the derivative of the first function times the second function that's just regular, okay, plus the derivative of that second function times the original function of that first, okay? It looks a little bit confusing, but just try and follow along. So let's look at example number 1 here, okay? So let's say I have h of x equals parentheses 3x minus 2x squared. As you can tell, that's my first function, and I'm going to be multiplying it with 5 plus 4x. Now, what you could do is you could FOIL this all out and then take a derivative. But when these start to get really, really long, you don't want to do that. Okay, so we're going to learn this product rule. So we're just going to follow this along. Does everyone see this first function? That's technically my f of x, and everyone sees the second function, and that's g of x? Okay. So what this rule says is take the derivative of your first. Okay, now knowing that power rule, what is the derivative of 3x minus 2x squared? Exactly. So I'm going to keep that in parentheses. So 3 minus 4x. That's technically f prime in this case. And then it says multiply it times your second function. Don't take a derivative of the second function, but just multiply it times your second function. So we're just going to put 5 plus 4x. But we're not done. We still need to take a derivative of this second function. So if we look at 5 plus 4x, what is the derivative of that? 4. And we're going to multiply it times my original first function, which is 3x minus 2x squared. And this is the product rule. Now what you could do is you can go through and simplify it, okay? If I did that, I'm going to get like 15 plus 12x minus 20x minus 16x squared plus 12x minus 8x squared. That's just some algebra for you. I'm going to go through and combine my like terms and put it in standard form all at the same time. So negative 24x squared, that's 24 plus 4x plus 15. So what this means is this is now h prime of x. Okay? That is the derivative of that top function. Okay? So, let's look at example number 2. Let's call it y this time. So y equals 3x squared sine x. Now some of you guys might be looking at this and being like, I don't see two separate functions, but there are. This 3x squared is being multiplied times sine x, right? So maybe just to help you understand that, you might want to put a little time symbol in there. Okay, and we're going to treat this exactly the same. Can anybody tell me what f of x is in this case? Yeah, just 3x squared, and then, which makes g of x my sine x, right? So I'm just going to follow that rule up top. It says take the derivative of this first function. Okay, well the derivative of 3x squared happens to be 6x. You see why that power rule is so important? And I'm going to multiply it by sine x. So that's f prime times g plus, now what's the derivative of g? Well, what's the derivative of sine? It is. So I'm going to have cosine x times, what's 3x squared? Now guys, word of caution. I see it happen. Doesn't happen real often, but do not go through and make this 3x cubed. These are separate functions. Cosine x is completely separated from 3x squared. Okay? And in fact, let's say I really wanted to get super fancy with this, and I'm kind of looking at this. Do these have any like terms that I could factor out? X and 3, right? They have a common factor of 3x. So if I go through this, I could actually be like, okay, well, let me factor out a 3x which would make, what do I have left here? Yep, I got 2 times sine x. If I factor out 3x from 3x squared, I have, right, so I'm going to put the x in front just so I don't confuse it as cosine x times x. You do not have to factor, but hint, hint, it's going to come in useful somewhere. Okay? You guys good? Okay. And the last one I want to talk about for product rule is this. Y equals 2x cosine x minus 2 sine x. Okay. It got a little bit trickier. Where's the product rule? Does anybody see where the product rule could technically be happening? Because it's under that category. Where's product rule? The 2x and the cosine x, right? But then what did I do right here? I tacked on a minus 2 sine x, right? So here's the thing. We're going to take this derivative, and then at the end, we're just also going to take that derivative. Remember, we can add and subtract all we want when taking a derivative. We don't have to use any special rule here. It's just understanding the derivative of what sine x is. Okay? So here's where we're going to use the product rule. Here we're just going to take a derivative. Is that clear? Okay. So y prime, again it says take the derivative of that first function. Well, derivative of 2x is 2 times just cosine x, because that's g of x, plus, okay, what's the derivative of cosine x? Negative sine x, times just f of x, which is 2x. And then, like I said, we already did our product rule. Now with this last part, all we have to do is take a derivative. So what is the derivative of sine x? Cosine x. And that negative 2 is just my coefficient, so negative 2 cosine x. Now as I look at this, is there any like terms I could combine? Is there anything I want to rearrange? Yeah, exactly. This positive 2 cosine x and that negative 2 cosine x will cancel. Okay, these are like terms. So y prime in this case happens to be, I don't really like the way this looks. It makes me a little bit uncomfortable, so I'm going to rewrite this as negative 2x times sine x. And that's your derivative. Okay? So that's product rule. Now, quotient rule. Quotient means to divide. Here is the quotient rule. So go ahead and write this down. This is what we're going to perform or use when we have a function divided by another function. I am not going to use low-de high, high-de low. I don't like it. Okay? So if you don't know what that means, great. If you do know what that means, you can use it if you want. So what you have here is you have f prime of x times g of x. Very similar. But when I'm using the quotient rule, notice this is now a subtraction symbol. Okay, it's not adding, I'm subtracting. And then it's g prime of x times f of x. And that's all over the original g of x function squared. It's over that denominator being squared. Okay? So again, we're going to apply this. I'm just going to write down the example that we're going to do. Okay? So here's our fourth example. Let's say y equals, and you know it's going to look rational, 5x minus 2 all over x squared plus 1. Okay. As you can clearly see, I have a linear function. It's being divided by a quadratic function. Okay. And I have to be able to take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So, here we go. If I am going to take the derivative, I'm going to say, don't put an equals there, sorry. Y prime is equal to, so let's start this. What is the derivative of your numerator? Use that power rule. Derivative of 5x minus 2 is just 5 times the bottom, which is x squared plus 1, minus the derivative of your bottom. So it's 2x times your top, 5x minus 2. Now guys, please, please, please understand, look at my use of parentheses. They're super important in this case because if I ever want to go through and simplify this, okay? So make sure you guys are using those parentheses appropriately. All over, what's your denominator? X squared plus 1, and I have to take that entire thing and square it. Okay? That is technically the derivative. Now, if this was a multiple choice test, you would not see it written as this because what they're going to do is they're going to go through, they're going to distribute and combine like terms. Okay? So if we go through and do that, we're going to get 5x squared plus 5. Most common mistake I see right here is dropping a negative like a baby freshman. Minus 10x squared plus 4x. Okay? And leave that bottom factored. So x squared plus 1 squared. If you have any like terms, combine them, which I do. So here in this case, y prime equals negative 5x squared plus 4x plus 5. All over x squared plus 1, that entire thing is being squared. Okay? All right. Let's make it ugly. Let's make it a little ugly. So, here's example 5. Remember, you have to get through 7 of them. So f of x is equal to 3 minus 1 over x, all over x plus 5. I have just made it super, super, super ugly. I know. I really did. And you're all upset, and that's okay. But guys, what don't you like? What's the part that you hate the most? Yeah, the 1 over x, right? And you don't like this right here. So what I'm going to do is I'm going to get a common denominator between them. So in this one, I'm going to multiply it by x over x. Here, I just need 1 over 1. Oops, 1 over 1. Do you see what I'm saying here? I'm going to get a common denominator, okay? So that's going to turn this function, I haven't taken a derivative, I'm just trying to make it look a little bit nicer. It's going to make it 3x minus 1 all over x plus 5. Okay? That doesn't quite help me out yet, but what could you do with this denominator? You could do the reciprocal, right? I could turn this into 3x minus 1 all over x times 1 over x plus 5. You okay so far? Then what could I do? What could I do with this miraculous little x here? I could distribute it through the bottom. You can't cancel it because it does not make the Seaman triangle. This does not have an x. Okay? So, you're going to get 3x minus 1 all over x squared plus 5x. I have just taken a function that looks really, really ugly in the beginning, right there, and turned it into something that's a lot more manageable. Okay? Now we can apply this quotient rule. So, f prime of x. Here we go. Look at that new and improved function, 3x minus 1. What's the derivative of that? Just 3. Times your bottom, x squared plus 5x, minus, what's the derivative of your bottom? 2x plus 5. Please make sure you guys are using parentheses. Times, what's your top? 3x minus 1. All over, what? X squared plus 5x. Squared, exactly. Now, ladies and gentlemen, before you get all super excited, you're all like, cool, this will cancel. No, it won't. Okay? It will not cancel. If you're going to cancel something, it has to cancel from all terms up top. This might have an x squared plus 5x, but this does not. Do you see that? You cannot go through and cancel these out. That is illegal. You are breaking a math commandment. Don't do it. Okay? What could you do to the top, though? You could simplify. Okay? So as I go up a little bit, and I'm going to simplify, maybe I'm going to get like 3x squared plus 15x. Now, I'm going to hold off on this negative, okay? I'm going to hold off. So, as I multiply through, I'm going to get 6x squared minus 2x plus 15x minus 5. See how I held off on that negative and I didn't distribute it right away? And that's still, leave your denominator factored, guys. That is the rule for this year. Leave things factored if they're factored out nicely. Like this is factored nicely. Okay? I'm going to go through, maybe distribute that negative, combine like terms. So as I do that, I have 3x squared. This will be a negative 6x squared. So I have negative 3x squared. I have a negative 2 and a positive 15. That will be 13. But since that negative is waiting for me out front, it's negative 13. So I end up having a positive 2x. And then negative times negative is a positive. All over x squared plus 5x squared. Okay? Guys, these take some practice. Don't stress out about it, okay? We'll be working on these for the next 2 weeks. Okay. All right, guys, and then I'm actually going to get through example 6, and then I'll leave example 7 for you guys. All right, here's example 6. So, f of x equals x cubed. Those are parentheses. I just made them really big. 2 minus 3 all over x minus 2. Okay? They are. Brackets can be used as parentheses. Okay, you're going to have a rough college experience. Okay, so ladies and gentlemen, as I look at this, looks really ugly, right? What was the trick that I used last time? Yeah, get a common denominator here, okay? So let's do that. So as I get a common denominator, I just need to multiply this 2 by x minus 2 over x minus 2, right? So this is going to be equal to x cubed times 2 times x minus 2 minus 3 all over x minus 2. Did I lose anybody there? Are we okay? Okay. Now I'm going to go through and simplify this numerator a little bit. So x cubed is equal to 2x. 2 times negative 2 is negative 4, minus 3 is negative 7, all over x minus 2. Now guys, I have a couple of things. I could go and do a product rule right here. I could do that, but notice this part has a quotient. So to make it a little bit easier on myself, I'm going to take this x cubed and actually just distribute it to my numerator. Okay? Yeah, because this is x cubed all over 1. And if we know anything about multiplying fractions, if you take 1/2 times 3/4, numerator with numerator, denominator with denominator, right? And you tell me this isn't a fraction, you can make anything a fraction. So multiply your numerators with the numerator, denominator with denominator. Okay? So this equals 2x to the 4th minus 7x cubed all over, this is still just x minus 2. And now we can go ahead and just use that quotient rule. Realize, I haven't taken any sort of derivative. This is just algebra. Okay? This is not calculus at all. This is algebra. Okay? We need to be able to set up our problems so that we are able to do the calculus. So, over off to the side here, f prime of x, as I'm looking at this, and I'll move it over a little bit so you guys can see it better. Okay? We're looking at this bottom function here, that one that I changed. Take the derivative of your numerator. What is it? 8x cubed minus 21x squared. You got it. Times what? X minus 2, right? Minus, what's the derivative of x minus 2? 1, thank you. It is not 0. Times, what's your numerator? Right. Ooh, I got a little smushy. Sorry. Okay? All over your entire denominator squared. Helps if I square it. Okay? This is technically a derivative. It's not going to look like this, though. We got to simplify. So as I go through and as I simplify that, f prime of x is going to be equal to, this is 8x to the 4th minus 16x cubed minus 21x cubed plus 42x squared. And I'm going to go ahead and take that negative 1 and distribute it to my parentheses over here. So minus 2x to the 4th plus 7x cubed. Whew, I made it. All over x minus 2 squared. Do I have some like terms up top? Absolutely. Let's combine them, make it look a little bit nicer. F prime of x is equal to, so 8x to the 4th and negative 2x to the 4th would be 6x to the 4th. Negative 16x cubed, negative 21x cubed, and 7x cubed. So what is that? That's negative 37 plus 7, so I get negative 30. Do we all agree? Check my math. Okay. Negative 30x cubed, and then I just have plus 42x squared. That's all over x minus 2 squared. And if I really, really was ambitious, what do all three of these terms have in common? 6x squared. Yeah, 6x squared. So you might see it written as this. 6x squared, which would leave x squared minus 5x plus 7 all over x minus 2 squared. Does this trinomial factor again? No, this one doesn't. So sometimes you have to look for that too. Okay? I know. Guys, let me just show you. This is the only part of the problem that was calculus. This is it. Everything else was algebra. So when I say 90% of the mistakes that in calculus come from the algebra, this is why.
This is advanced algebra.
Exactly. Okay? So, that's what I have for you guys for today.
And then number 7?
I'm going to hold off on number 7 until tomorrow.